Hello and welcome to another episode of Math with Dr. War. Today we're going to tackle probability. Now on the task test, there are two types of probability you're going to come across. The first one is theoretical probability. This is what we call mathematical probability, and it's the measure of the chance that an event occurring in any trial of the experiment. And it's written P of E, where E is the event, and it's the number of members of the event E over the total number of possible outcomes. Another type of probability you're going to see on the task test is called relative frequency. Now, my students were quite surprised when they saw this word, relative frequency. And relative frequency is just experimental probability. So relative probability can be called experimental probability. You have P of A, it's the frequency of the event, which we'll call F, over, again, the total number of possible outcomes, N. In all, probability is probability. It's the members of the event over the total. That's it. Now, whenever you see P of A, when it looks like this in the notation, it just reads P of A, and it's basically the probability of event A. Now, one of the things you have to remember about probability is that it is a fraction, and probability lies between 0 and 1. Your probability can never be less than 0, and it can never be greater than 1. Now, if your probability is 0, it means that it is impossible. If an event has a 0 probability, this means that it can never happen. So that's just like when I was growing up, I used to ask my mother for certain things, and she would always say sometimes if pigs could fly. We all know pigs can't fly, so the probability of that is 0, which means impossible. Now, if an event has a probability of a 1, it means that it will certainly happen. That's just like if I ask you, will the sun rise in the east tomorrow? The answer is yes. So the probability of that happening is 1. It is certain to happen. Now, if an event has a probability of a half, it means that you have an equal chance of it happening. An example of that would be flipping a coin. You can get heads or you can get tail. It's a 50-50 chance. Now, if a probability lies between 0 and a half, it means that it's unlikely to happen, but not impossible. Example of that is I don't like to take buses. So the probability of me taking a bus is unlikely. It's not impossible, because if the train stops running, I'm going to have to take a bus. But it is unlikely. I will do my best not to take a bus. I'll take an Uber, I'll take a Lyft, I may walk, but it's not impossible. Sometimes I have to take a bus. Now, if an event is between 0.5 and 1, then it's likely to happen, but not certain. An example of that would be the probability that I will answer my phone in the next hour is likely. So always remember, theoretical probability is just mathematical probability. Relative frequency is another word for probability. That's a new word they've been using, and it's basically experimental probability. And just remember, probability lies between 0 and 1. 0 means impossible, will never happen. 1 means certain it would happen. If it's in the middle, it's a 50-50 chance. If it's between 0 and a half, it's unlikely. And if it's between a half and 1, it means it's likely to happen. Let's look at some examples. So I've tried to find different examples that show the range of probability questions. My first question states, on Roberto's shelf are 6 mystery books, 5 science books, 4 history books, and 3 adventure books. Roberto will randomly choose one book to read. What is the probability that he would choose an adventure book? So how many adventure books do he have? He has 3 over total number of books. We need to add this. So we add 6 plus 5 plus 4 plus 3. That would give us a total of 18. There's our probability. So I always tell my students, because the task test is a little bit, I would say, funny. And funny where sometimes they don't reduce their fractions. So if you get 3 over 18, just check to see if it's there. Okay, I noticed it's not there, which means your next step is we have to reduce this fraction. Now 3 and 18 are both divisible by 3. So let's go ahead and divide by 3. And my answer is 1 over 6. So my answer is D. Now, if you're on the calculator section and you're going to use the calculator, again, you enter 3, press the fraction function. Let's enter 18. Let's go to the right. And all you have to do now is hit enter. And when you do that, the calculator will reduce your fraction. So notice you get 1 over 6. A student is equally likely to select pizza, nachos, or chicken for lunch. What is the probability the student does not select chicken? So the key word here is does not select chicken. So if the student does not select chicken, they're either eating pizza or nachos, which means they have 2 choices out of a total of 3 choices. So your answer is 2/3. This is reduced in lowest terms. So my answer is C. The thing with probability questions is reading very carefully and thinking critically, because I find these problems are not difficult, but you have to read carefully. Okay, here we have a bag contains 5 green gumdrops and 6 red gumdrops. If Kim pulls a green gumdrop out of the bag and eats it, what is the probability that the next gumdrop she pulls out will be red? So we want the probability that she selects a red gumdrop. And how many reds do we have? 6. But remember, she ate a gumdrop. So how many gumdrops were they all together? In the beginning, she had 5 and 6. So she had a total of 11. But remember, she ate a green one, which means she only has 10 left. So our probability is 6 out of 10. So our answer is number 4. And notice they did not reduce it. So that's why I always tell my students, when you write your fraction, check, because for some reason, sometimes they don't reduce. I notice with probability questions, they like to give tables. Now, these tables are what we would call a relative frequency, because you see the word here, frequency. And sometimes when they write their problem, they don't say find the relative frequency. They'll say find a probability. I know, it's a little bit confusing. Why do they do this? So this question states, the students in Mrs. Nazir's mathematics class toss a 6-sided number cube whose faces are numbered 1 to 6. The results are recorded in the table below. So these are your results and these are your frequencies. What does this frequency mean? It means that when the student threw the cube and they got a 1, this occurred 3 times. When they threw it and they got a 2, this occurred 6 times. So that's all it means. Now the question states, based on these data, what is the empirical probability of tossing a 4? So we want a 4, so here's a 4, and that occurred 6 times. So that is 6. And what is our total? So we have to add all of this. So let's get our calculator. So we have 3 plus 6 plus 4 plus 6 plus 4, and we're adding 7. And our total is 30. So our answer is 6 over 30, and again, they did not simplify. So our answer is 2. Next question. There are 4 students running for student government president. A survey was taken asking 100 students which candidate they would vote for in the election. The results are shown in the table below. So again, this is another relative frequency because here are the candidates' names and these are the number of supporters, which is the frequency. Based on the table, what is the probability that a student chosen at random will vote for LaShawn? So we go to our table, we find LaShawn. 14 supporters said that they would support LaShawn out of a total. Now sometimes you don't have to add. I find sometimes they give you the total in the problem. So if we go back up here, it says a survey was taken among 100 students. So your total is 100. If you want to check, let's check. So we have 30, let me write it here. We're adding 30, 28, 14, and 28. Now 8 plus 8 is 16, plus 4 is 20. So we have 2, 4, 6, 7, and 3 is 10. There you get 100. So again, read carefully because sometimes they do give you the total in the question. You don't need to add. Now again, 14 over 100. I look at my answers. I don't see that. Okay, let's get our calculator. So 14 N over D, 100 to the right. And we hit enter and it simplifies to 7 over 50. Again, if this was on the non-calculator section, 14 and 100 are even numbers, and even numbers are divisible by 2. 14 divided by 2 is 7. 100 divided by 2 is 50. The party registration of the voters in Jonesville is shown in the table below. So again, this is another relative frequency. So here are the registered voters in Jonesville. This is the party registration, Democrat, Republican, or Independent. Number of voters registered. If one of the registered Jonesville voters is selected at random, what is the probability that the person selected is not a Democrat? So if you're not a Democrat, it means you're a Republican or Independent. So we're going to have to add these two. So 0, 0, that's 10, 8, and 1 is 9. So that would be 9,000 that this event occurred over, and then we have to get the total. So now I just have to add 6,000 to that, which would give me a total of 15,000. Now, if you notice, sometimes your answer can be a decimal. So suppose we use our calculator. So we put 9,000 N over D, 15,000 to the right, and we hit enter. It simplifies to 3/5. And remember, we want to change this to a decimal. So remember our little friend here, which converts our fraction to a decimal? If we press that, notice I get 0.6. And let's look at our answer right here. Okay, our next question states the school bus EV rides is scheduled to arrive at her stop at 8:20 a.m. each day. The table below shows the actual arrival times of the bus for several days that were randomly selected over the past month. So these are all the bus arrival times. Now, based on these data, what is the probability that the bus will arrive at EV's stop before, and the keyword here is before 8:20 a.m. tomorrow. So we want the bus to arrive before 8:20. So let's go down this first column. No. No. Okay, this is before 8:20. Also this and also this. Okay, no. Before 8:20, before, and before. So it occurred 1, 2, 3, 4, 5, 6, 7. So it occurred 7 times out of, and how many was this? So 1, 2, 3, 4. So if we go down this way, it's 4. And if we go this way, it's 1, 2, 3, 4, 5. And 4 times 5 is 20. If you want to, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And this is in simplest form, or you can go from here you see your answer is C. Now, there are some types of probability questions that are called conditional probability. And these two questions represent those. So it says, throughout history, many people have contributed to the development of mathematics. These mathematicians include Pythagoras, Euclid, Hypatia, Euler, Einstein, Agassi, Fibonacci, and Pascal. What is the probability that a mathematician's name selected at random from those listed will start with either the letter E or A? So they wanted E or A. Okay, so how many E's do we have? 1, 2, 3. So 3 E's out of a total of 1, 2, 3, 4, 5, 6, 7, 8. So that's 3 out of 8. The probability that a mathematician's name begins with an A, there's only one A, that's Agassi. That's 1 out of 8. Now the word or has a very important mathematical symbol. Whenever you see or, it means addition. So we have 3 over 8 plus 1 over 8. And remember from my fraction video, when the denominators are the same, you keep the denominator and you're going to add the numerators. 3 plus 1 is 4. I get 4 over 8. And again, check the answers. So your answer is C. Now here's a little tip. They're not going to have 4 over 8 and also a half. They cannot. That will be ambiguous. So they're either going to have 4 over 8 or a half. They're not going to have both. So that's why I always say, when you get your fraction, check first. Don't reduce. Only reduce if you do not see your answer present. A bag of fruit contains 3 apples, 2 oranges, 1 banana, and 4 pears. Gerald would randomly select 2 pieces of fruit, one at a time from the bag, and not put them back. Here's the key word. He's not going to put them back. What is the probability that the first piece of fruit Gerald selects will be a banana? Okay, so we got 1 banana out of a total of 3 plus 2 is 5. 1 is 6 plus 4 is 10. So if he selects a banana, it's 1 over 10. And then here we have the keyword and. Now the second piece of fruit would be a pear. How many pears do we have? That's 4. But remember, they said he's not going to put the fruit back in the bag. So that's 4 out of 9. Whenever you see the word and, it means to multiply. And remember from my video, when you're multiplying fractions, you go straight across. 1 times 4 is 4. 10 times 9 is 90. I get 4 over 90. I do not see it there. 4 and 90 are both even. So when I divide by 2, my answer is 2 over 45. Do I see that there? Yes, I do. My answer is G. So when it comes to the conditional probability, if you see the word or, you add. If you see the word and, you multiply. This is what we call a bivariate categorical data table. And this is what we call a two-way table. These are a little bit tricky, but you have to read carefully. So it says here, on Saturday, Ari surveys 200 people at a music festival. She asked the people if they are camping overnight and if they're attending the festival on Sunday. She makes the two-way table shown to display her results. So this is her results. So if you're camping overnight, not camping overnight, and then the columns are attending on Sunday, not attending on Sunday. So you have an idea of why it's called a two-way table. She's looking at 2 things. Are you camping overnight or not camping overnight, which are your rows, and then your columns are attending on Sunday or not attending on Sunday. The question states, a randomly selected person from Ari's survey is not camping overnight. Okay, so we're looking at this. They're not camping overnight. Okay, so let me circle it. This is my focus here. What is the probability rounded to the nearest whole percent? So now they want their answer as a percent. The randomly selected person is attending the music festival on Sunday. So notice, attending the music festival is 57. Now, if you're not camping overnight, then the total number of people would be 57 plus 57, 114. So we want to know, rounded to the nearest whole percent, that a randomly selected person is attending the music festival on Sunday. So that would be 57 over 114, 57. So I have a feeling when you simplify that, you're going to get, so if you take 57 and divide it by 114, you get 0.5. And 0.5 is 50% because it's a half. Okay, the last one, I tried really hard to find a relative frequency. I could not. That's why this video is so late. I was like looking all over the place for a problem that just said relative frequency. However, I was happy to came across this problem, which is also a two-way table. Eastview Junior High students ordered sweatshirts and t-shirts in either purple or gold. Of the students who ordered a sweatshirt, the relative frequency, and remember relative frequency means probability, the relative frequency of ordering a gold one is half. So if you wanted a gold, that was half of the relative frequency of ordering a purple. Which two-way table shows the data for the orders? So we're looking at sweatshirts. So we're looking at the first column. And they said the gold was half of the purple. Now if you look at A, this is the opposite around. Look at your goal. Your goal is 24 and the purple is 12. Remember they said that the gold was supposed to be half of the purple. So if purple is 12, gold should be 6. So this is not our answer. The purple is 28, so the gold has to be half of that. So that should be 14. So okay, this is not our answer. All right, over here we have the purple, which is 70, and the gold has to be half of that. Half of 70 is 35. Yep, so our answer is C. Always remember that there are two types of probability. Theoretical probability, which is just mathematical probability. And if you see relative frequency, it means probability as well. And remember, probability is the number of members of the event. I like that word number of members because when it says possible outcomes, students get a little bit confused. So I like that number of members of the event over the total. And just remember, probability is between 0 and 1. 0 means impossible, 1 means certain to happen. If it's halfway, it means it's a 50-50 chance that it will happen. I hope this video has been helpful on probability. Good luck on your TAS examination.